engineers. Here we go. Hey everybody, welcome to Data Engineers Lunch number 7. This is the first Data Engineers for the year. I'm still getting used to writing 21. I was just like, that seems so weird. Today's topic is just relational databases. We have covered, and I'll show the outline in a second, we've covered various topics about data engineering in general. And this is basically on the itinerary for becoming a data engineer. So, unless we have volunteers to come talk about something they want to talk about, we're just going down the guide to being a data engineer, basically. So Akwi, thanks for being a co-organizer. Akwi helps produce this event and gets the webinars recorded and uploaded and the blog posts with the references all out there. It just seems like magic, but it's Akwi taking the lead on that thing. So Akwi, we're always looking for, really looking for speakers to talk about anything related to data engineering. But if you want to help kind of co-organize, happy to have you help the group here. We're part of a larger community called Data Community DC. We believe in diverse communities and welcome people from different backgrounds, especially if you know somebody who's from an underrepresented community. Love to have them speak about something. Data Community DC has the following groups. We're just one of them. If you want, check out datacommunitydc.org, and they have links to all the groups and all the meetups. What we cover here is not only the process of data engineering, but the process of becoming a data engineer. And I think they kind of go hand in hand. Data engineering changes as data systems change, and data engineering thus changes in the sense that we have to learn new things. Data engineering in general is the processing of information for the purpose of helping people do business intelligence, helping people do machine learning or data science, or just explore clean information. All right, we have a couple of folks. So Abe, and I think there's Fuchida as well. Abe, just introduce yourself. What do you do with data? What would you like to learn? What can you present on?
So I just finished a data science boot camp. It's called Springboard, and I'm looking for data analyst or data engineer roles right now in the DC area. And part of the Springboard boot camp is just getting a lot of hands-on experience doing full-length projects, like end-to-end. So I've written web scrapers to, one of my projects is like a KBO Projections, which is the Korean baseball organization. When sports first went down at the beginning of the pandemic, that was the only sport on TV. And so I was like, oh, this would be cool to model some of the project player performance and see if there's any KPIs that can tell you how players will do down the road for the season and just see how those performed. And so, yeah, I'm wanted to be a data scientist when I started, but I realized that might be a little ambitious right off the bat. So just looking for those types of roles in the DC area right now. And yeah, I love scikit-learn. And I don't know if there's anything I could present on right now, maybe, but yeah, I'm really passionate about data and using it to draw actionable insights that are like database decision making, I guess is what I'm trying to say, because so many decisions people make are just arbitrary based off of some principle that they have.
Right.
So that's my deal.
Great, yeah. Maybe you could present on web scraping. It's a perennial topic actually as technology. Great. We have a couple other new folks. There was a person, Fuchida. He or she is no longer there. Lindsay, if you want to just quickly introduce yourself. What do you do with data? What do you want to learn, or what can you present on?
Sure. Hey, everyone. I'm Lindsay Cooper. I currently work with data as a contractor with the Department of Homeland Security, primarily financial and procurement-based data, working on a financial system migration right now. But for fun, my real interest is in crime-related data. So currently I'm working on a program in Python that'll pull data from Washington DC's like open source records and yeah, map crime related stuff. I'm still in the pretty beginning phases of that, but yeah, I just found this group and was intrigued and just wanted to see what it was about.
Great.
So thanks for having me.
Awesome. Rachel, or is that how you pronounce it?
Rachel, yeah.
Yeah, go ahead.
Hey everyone, I have not been to this meetup before, so excited to join. I am a data scientist for Atlassian, but I dabble in the data engineering, just having some like Databricks jobs for data modeling and stuff like that. So always helps to learn a bit more about that side of things. And yeah, excited to see what this group is about.
Great. And it looks like Chuba rejoined. Chuba, if you want to just quickly introduce yourself, if you can hear us. Oh, he's connecting, he or she's connecting via audio. Okay, we'll come back to, hey Chuba, can you hear us? Okay. Anyways, we'll continue forward. Group rules, if you have a question, ask it, be polite. You can ask it in the chat or you can ask it, just unmute yourself and just yell it, don't yell it out, but you know what I mean. It's an opportunity for you to share something that you know. Also, data wranglers, I took this group over several years ago, but it has always been a community where each topic is the discussion, it's not a presentation. So if you have something to add to the conversation, just come right in. Our company, Anant, we are specialists at real-time data platforms around Cassandra, Spark, and Kafka. DataStax actually is a partner and a sponsor for this group, as well as DataStax Cassandra DC and DataStax Cassandra Chicago. As is the George Washington University, who has been a great host to a lot of Data Community DC and Data Wranglers DC events. As they start to open up, we'll figure out a way to get some physical events going. And we have some local sponsors in Chicago and DC, always looking for sponsors for this group, as well as the organization. Data Community DC is a 50C13, I think that's the right way to say it. Which is it's a nonprofit that basically educates people in the DC area about data. So these fine companies get a tax deduction for advertising, basically. Any announcements? People looking for jobs, people that have roles that they want to hire, meetups, hackathons, conferences. So Abe, you mentioned you're looking for some work.
Yep, I am looking for any like entry-level data analyst, data engineering positions. Yeah, I'm passionate about data. If anyone knows anything, just give me a shout out.
Yeah, drop your LinkedIn, maybe an email address on the chat. We're actually always looking to hire data people. So maybe we can have a conversation. Anyone else with any announcements? Okay. So we don't have any upcoming events. It's just a brand new year. We had a bunch of events the last few weeks. Data Community DC has lots of events all the time. We have this weekly lunch call that we started a few months ago, every Monday, same time, same place at noon. And as there are other data engineering events other than this event, we'll keep this updated. All righty. So if you're new to the group, basically, as I was mentioning, we've been covering a backlog of requests that people have had, and some people want to present something so we go ahead and put it on here, as well as if there's not a speaker per se, we have a general path to becoming a data engineer, learning programming, different shell scripting, different types of databases, data processing systems, scheduling systems, you name it. Today, we're going to cover just this part here, relational. And as I mentioned, if you want to discuss it and ask questions about it, just feel free to drop in. We've covered to date ETL frameworks, shell scripting, shell automation, Airflow for data engineering, what are data lakes, common data storage formats, file formats. And all of these are on the group. We have a YouTube. So Akwi, if you could put the YouTube link in the chat as well, if you want to catch up. So, what are relational databases? Well, there's a few key topics that I wanted to get across from a conceptual standpoint, and then talk about some popular databases, as well as the common known advantages and disadvantages that I encounter and I've seen other people encounter in the relational world. I actually found a great presentation on the history of the database. There's one by an Oracle person that was pretty good, and there's another one from like an Oxford University course. But rather than reinvent the wheel, I just wanted to kind of quickly run through the core concepts and the history from these decks. So, generally speaking, relational databases are used for data that's tabular, although now relational databases can store hierarchical information in the form of JSON or XML as well. And if you have multiple types of a particular entity and you have multiple relationship types, the best thing about relational databases is that you store information once and you can query it different ways. Opposite of that is obviously the non-relational world, which there's different types of non-relational databases. In relational databases, most of them are very synonymous in terms of the core features. It's built from a history. Here's a question or something. Thanks, Akwi. Relational databases have been around for a long time, but they were engineered when memory and disk space was very expensive. So, it's really geared towards avoiding the duplication of information. If you have normalized your database to the fifth normal form, you literally you don't have any duplication. Like even male and female as a value will be stored as gender ID, for example. So let's say you have this tabular data in the mainframe world, it would be stored just like this. But as relational databases started to come around to replace mainframes in terms of data store, people started to think about how can we better optimize the storage of this data. So as you can see, there are some duplicates already in this information, like the type, the author, and the publisher as well. So what we can do is we can say, how can we store this information once and refer to it or get this data from that one place. So what we do in relational databases is we take data and we separate out, we normalize information into its kind of like lowest common denominator, basically, right? And we say, you know what, we're going to have a table for authors. So in this case, for example, there's two people by the name of David Mitchell. They have different birth dates. We're going to be referring to that author in the record, okay? And we'll talk about how that's done. Publishers can be put into a different table, right? We'll refer to that publisher. And we can also store the type in another table. And the title itself, you can even go a bit better and have title, and you can have an edition number, for example. So the book title could be its own database, a table. The storage engine in a relational database is basically modeled around a row and a column. So a database has a collection, is basically a collection of tables. A collection of tables is named different things in different databases. So sometimes people call it a schema, sometimes people call it a key space in other databases, but a database is just a collection of tables. It's important to think about this concept of a database as a collection of tables, because you're going to be, when you store data in a relational database, you're going to be potentially joining tables together to get the data that you want. Each row is a record or a row, and then each column is a field. People name them different things, but each of the fields also have a type. It's a type of a field, for example. So one thing could be a text, one thing could be a number. Normally, when we design a table, design a database, we draw it out on paper or a whiteboard. And I'll quickly show you guys like an ERD diagram. So this is more of an ERD diagram, but most people may be used to seeing a database map like this, right? The table and what's the primary key. And in this case, for example, we don't necessarily know if it's a text field or a number, but when designing database, there's different tools to do it. Starting out on paper is a good way to just say, okay, what are the fields I'm going to have? And what's the foreign key and primary key relationship between these tables? The type of data in a relational database, it depends on the database that you're using, but you can have text, date. In some databases, you can even make your own data type. Like for example, in SQL Server, you can have a data type that you create in C# or in Oracle. I think you do it in C++, or I don't know if it's PL SQL or C++, but there are ways to do hierarchical objects now that are basically, it's an object that you store in a database that's not stored as a field. It's actually stored as a data type of that type in that programming system. I'm not going to go through this whole deck, but the history of the database is where I also wanted to spend a little bit of time so you guys can understand where it all started. So in the 60s, as computers got a little bit cheaper, this guy, Codd, proposed, the relational database model, organizing it, and the Codd design principles are something that you're going to see if you study relational databases. And this guy named Chen basically proposed this entity relationship model, which I was just briefly showed earlier. In the 80s, Ellison basically took the paper on relational databases from Codd, and he made the first database, commercially available relational database. That's why Oracle is a thing, because somebody took a white paper or a research paper and made it. Quick tangential history, Microsoft is Microsoft today, not because of Windows, because they took the basic paper on the programming language BASIC and implemented it for a particular hardware. In the mid 80s, SQL, some people pronounce it SQL, structured query language. It's the basic, it's a standard. And even with the relational databases today, we see that SQL is here to stay. So in data engineering in general, SQL is like a first class citizen next to Python. Like you should know it, because eventually either you're going to be pulling data from a relational database or you're going to be putting data into a relational database, and you better know SQL or you're going to be SOL. In the 90s, this is when we see other commercial databases, we see open source databases, And this is a slightly old deck, but when the internet became a thing, other databases started to become very prominent. So MySQL, really in the early 2000s, that's actually, they don't really get into the early 2000s, but MySQL was one of the most popular, is still one of the most popular relational databases out there. It's been around for a long time. And there's another database called Postgres that's open source as well. And it's probably one of the best technologies to move from Oracle to, because it has a lot of similar characteristics. Yeah, I'm not going to go into the database design process, but key things about a database to just be, to know is there are data types, there's foreign keys, there's primary keys, and foreign keys and primary keys can be related together, hence relational database, right? This relationship between a table and another table, once you set that relationship up, if you were to, for example, delete a parent object, you can cascade that delete to the table that's referred to by the foreign key. This application of data with relationships is one of the most important reasons why people use relational databases, is because this idea of referential integrity. The relationships that are there are kept together, and it is a transactional system in the sense that the data is exactly what it is when you look at it. And if there's a competing operation that's about to come, it won't let it happen unless that's done. If you have a lot of memory and CPU, it can kind of handle it very fast and you won't notice the difference. So talked a little bit about the history of relational databases. Another thing to note here is that if you go to the history of Postgres, and it's probably evolved from Ingress. So Ingress was another database that was very popular alongside Oracle, but it came out of the the same time frame, but it came out of Berkeley. And at the same time, people took that database and they made Sybase. And then SQL Server is basically Sybase, but bought by Microsoft. And nowadays, Postgres is a first-class database itself. So Postgres is closest, in terms of open source technology, it's the closest to the roots of relational databases. It's an amazing database. Sorry, I don't need to have my to-dos up right now. Why do people need relational databases? I hear the same question as I become older and have a few more gray hairs. As younger folks come, they say, why do people still use Java? It's like 25 years old. Like, why do people still use Java? I'm like, well, that's a different discussion. But why do you still need to use relational databases? Isn't that old technology? Well, no, actually, it's a great technology, and because it's old, it's really mature. It's used these days because it's the fastest way to have data stored and for you to do any kind of like analytical processing, complex joins, complex calculations in SQL. SQL has calculations, math processing that you can do in the SQL language itself. So that's why people still use relational databases. In fact, they'll have massive non-relational databases, and they'll have a data engineering process that churns it and then produces a relational database so that data analysts can connect their Tableau or Power BI to the database and do queries from it. The other thing is that a lot of people know SQL. In fact, it's tied to this BI. Data analysts that are comfortable with SQL and they're comfortable with the BI tool can use the same core SQL language with any database that supports SQL. So Postgres, MySQL, SQL Server, Oracle, IBM DB2, you name it. And SQL has two flavors, data definition and data modification. Data definition is where you say, I want to have a table and here are my fields and here's my data type. Well, that data definition pretty much looks the same in all databases that support SQL. Or data modification, select, insert into. That's basically the same. There may be some things that are off, but they should be supporting something called ANSI SQL. Big data tools, Spark, in our wheelhouse, is basically a distributed computing system, but it has Spark SQL. And Spark SQL represents data if it's stored in another database, or if it's stored on a distributed file system. It represents that data as a data frame, and you can do SQL between data frames backed by different data stores. So I would just say it's like, I don't know why I said this, but it's one of the most in-demand industrial skills that you can have. Rules of design, I don't think we're going to have time to go through rules of relational design, but we can come back to it. But I did want to cover normalization really quick. The process of normalization is see if Google will give us a good image. This is just kind of one normalization, process. If you have data that's tabular, as we're looking at, normalizing it would mean that everything that's unique would be in a table, right? Projects, employees, rates versus projects underscore employees would have the data related to it. There's different normal forms, first, second, third, and then the COD normalized form is the most how do I say, it's the data model with the least duplication. Like literally nothing is duplicated. Everything is referred to from another table. Highly normalized databases become very hard to understand. And you have to decide whether you want to make a database that is, quote, efficient in storage, or if it's useful for people to query. And in that case, like table design is almost like a user interface design. How are people going to perceive this information? How are people going to be joining this information? If you're using a database that is transactional, meaning that database is used to store and retrieve data while you're doing analytics on top of it, you may want to separate out the analytical data base from the transactional database. And that analytical database may have a different structure to it. In data warehouses, which is a different technology, data warehouses use SQL to retrieve information. They store data slightly differently, but when you're creating a data warehouse, you're creating queryable tables that people can quickly understand and filter information from. There are whole courses on normalization of data. And in the non-relational world, or the NoSQL world, we talk about denormalization of data. But it's a whole different topic. I learned normalization through these kind of pictures. I did not have Google images before, but basically, if you're trying to understand something in data engineering, look for it on Google Images, and you'll find a picture that explains it. So, all right. Any questions or comments about what we just covered? Kind of like the high-level overview of relational. Any comments? Okay. So popular SQL databases, there are lots and lots of SQL databases, like too many. But these are the ones I still see in use at work and on open source projects. H2 is a Java in-memory database, which you can basically only use in Java. SQLite is another file-based database that you can use with a lot of different programming languages. So you can use Python with it. You can use C++ with it. It's uses a Berkeley DB database format, but mind you that SQLite is not meant for big data. Where you will see SQLite is like temporary storage of a data process. And then they throw away the SQLite database after that. Or it will be used for configuration data for an engine for data processing, like metadata or schedule information of the process. Access, Microsoft Access is one of the most, I don't know how many people still use it, but as far as I know, a lot of small businesses, they used to store a lot of data in Excel and in Access. It usually went like people would store data in Excel, and then they would graduate to using Microsoft Access, and then they would graduate to using SQL Server. Both SQL Server Database Engine or SQL Server Express and Access are file-based databases, meaning you don't necessarily have to have the server running. You can just essentially have data there and use it with a simple service. Open source databases, I mean, the most common ones I've already mentioned. MySQL, another flavor of MySQL is, because Oracle bought MySQL, is MariaDB. If you want to be truly open source, you can use MariaDB. And then on Amazon, there is MySQL RDS, which is their kind of database as a service. Actually, I should prefix this with AWS. There's also something called Aurora DB for MySQL on AWS, which is a master. It's a newer technology for doing master replication of data. And then in the MariaDB world, there's an open source thing called GaleraDB. And these all support MySQL syntax. And if I want to keep it fair, we can also add on here something called TIDB, which is a MySQL compliant new SQL database, which automatically shards information, and we'll talk about that in a second. Postgres, lots of different. So there's a database called Greenplum. There is something called Cockroach DB, Yugabyte DB. There's another, I think another one called Citus. So these are technologies that all end up using the Postgres standard for database DDL and DML. Right. So if you learn these two databases, if you learn SQL on these two databases, you're covered. Like you're good. You don't have to worry about it. I shouldn't say that, but you will basically know how to deal with a lot of different databases. And then on the commercial side, Oracle is still, you know, in terms of like use, the biggest companies, they use Oracle, and then they started to use non-relational databases, and then they started to replace parts of Oracle with Postgres. I have used Oracle. You should not compare Oracle to MySQL or Postgres. It's like comparing, you know, a Boeing 777 with like a Cessna, right? They're in completely different worlds. Like Oracle is kind of a big deal in terms of what it does for businesses. But the reason people are moving from Oracle to Postgres is because systems are no longer monolithic. They're breaking everything down into microservices. And the role of SQL is really becoming, I wouldn't say limited, but it's getting carved out for like, you know, analytical BI purposes, or something like Postgres can store the data and you can do queries on it, and it can scale to a certain degree similar to Oracle. SQL Server has its roots in Sybase. Microsoft basically bought Sybase, and they I don't think they OEM'd it. They basically bought the rights to that code, and then they started improving it. So SQL Server has been I would say it's improved significantly since 2000, which was, I hate to say it, like 21 years ago. But you know, SQL Server 7 Some people still use SQL Server 7, but SQL Server 2000, 2005, people still have the old installation. It's a good database. But the reason people use SQL Server is because they were small businesses at that time. They started using Access. And then SQL Server was the logical step to use right after Access. And then as they grew, SQL Server as a technology grew. So it supports XML data types. I think it supports JSON. It supports C#, CLR data types. It got pretty good replication. It's a pretty good tool. Now, SQL Server has its own ecosystem of tools on top of it, just like Oracle. So people use things like SQL Server Reporting Services, which is a poor man's Tableau. But just because it's commercial, and as the trends go from open source to commercial, I wouldn't discount it. And in fact, recently, SQL Server now runs on Linux. Sybase is still around. I found this surprising, but some people still use Sybase for very, very large databases. And so one quick thing to note about Oracle is that Oracle has something called PL/SQL, which is proprietary to Oracle. And then SQL Server and Sybase has something called TSQL. I've been involved with like tuning SQL Server, and their whole database runs on something called SOS, which is a SQL Server operating system. It's fascinating when you get into the internals of a relational database. Advantages. Okay, before we go to advantages and disadvantages, any other databases that you guys have encountered that are relational that we haven't covered here? Okay, let's go to advantages, disadvantages. This is not an exhaustive list. In fact, I copied a bunch of this stuff from one of these other articles, but it's a good starting point. Relational databases have, if they're done right and the indexes are properly designed, it's instantaneous. And I should also add, if it has enough hardware, it's instantaneous. You can write data and retrieve it, fairly quickly, and it goes through the ACID. It has ACID properties in the sense that it's atomic, it's consistent. What does ACID stand for? I just had a senior moment. Atomicity. Here we go. Right now, I only deal with basic databases. Atomic, consistent, isolated, that's the word, isolated, and then durable. Whereas base is basically available, soft state, eventually consistent. What does this mean? It means that when you're writing data, if it's related in another table, when you retrieve that information, when I say referred, like it's a foreign key, private key relationship, when you refer to that data, it will retrieve that information. But if there's a write operation, that write operation has to wait until that data has been sent. And the reason is that the database will not send you old information because it has to make sure that any user of that data is getting the most current information. Or for example, if you are writing two operations at the same time to the same row, it will lock that row so that it can update the first, you can do the first operation, and then it will release the lock so that you can do the second operation. This assures that everything happens in a particular sequence. It's very deterministic. You can have a database transaction log that basically can replay the whole database in the same exact order that the data came in. I wouldn't say no coding skills. I mean, you need to know SQL, which is kind of a programming language. And you can do, average, sum, max. You can do casts from data types. You can do some basic programming here. And you can do data processing in SQL as several different stages using things like select star from this join, insert it into this other table. So you can do a fairly good amount of coding in SQL. I think when I say no coding, you don't have to know procedural or functional languages like Python or Scala, right? It's just data manipulation. It's pretty easy to pick up. And once you know it, it's available. You now have the ability to interact with most of, if not all of the databases here, right? It's portable, right? Everybody uses it. The technology can be embedded into a program using a file-based database, or you can have a server that's running on Linux, Mac, it doesn't matter. It provides you one way to get to that information, SQL. Most databases in this realm here, which are not file-based, you have a way to interactively query data and insert data and delete data and see what's happening. There are clients, applications that you can use to talk to these databases, and they give you that same feel. But in a server environment, many different users can be doing this SQL operations in real time in an interactive REPL environment, right? And then finally, this is why people still use relational databases. You store data once, you can query it 100 different times. That's why people want to use it, because one data analyst may want to do one type of query, another data analyst might want to do another data query, which is not as easy in a non-relational world. That's just how it is. Some disadvantages, and this is from my knowledge, and there may be new relational databases that kind of get around this, but there's a fixed set of columns, meaning every record has those columns, whether or not you set them, right? It has a placeholder for it. Whereas in a non-relational database, it only stores what you set it. So, you know, when you have new columns, you want to have new column, this is hard to do if you don't have, if you have a relational database. So this is a no SQL feature that people started to really like. I want to add another value, but I don't want to alter the schema of the database itself. Pivoting, you know, on queries with, you know, dynamic columns. I've seen this happen on some databases, but like MySQL, it's not as easy as it is in, let's say, SQL Server. So it depends on what you're using. As I mentioned earlier, to achieve ACID, you need to lock data. You need to create locks. That means that there's a finite limit to how fast you can read and write data on one machine. And then the only way to scale is either master-slave replication, where you have a master that does read and writes, and you have slave servers, which are read. Well, people now call them, like, you know, read replicas, which are basically taking data from the read-write server, and they're just serving reads of information, but all the writes have to be sent to the read-write replica. The other way that people scale is using some of the newer technologies like Galera or CockroachDB or TIDB, which is essentially using no SQL distributed data storage mechanisms to provide a relational view of the data, but it's not truly relational in the sense that you don't have locking without a cost. So sometimes the reads and writes are going to be slower because of it. Or Slack, for example, and they may have changed their design. Slack is down, or no, it looks like it's up now. It was down this morning. Slack, I read a paper on this. They use MySQL, for example, to run, at least when I read the paper, they use MySQL, and they would have a different server, and they would shard their customers on different servers. Sharding just means that, let's say you have a customer list, you would say, I can't fit customers A through Z on this one server, so we're going to have, let's say, 10 servers, and we're going to equally divide up the customers and put them there. Now, the application may need to be configured such that when I go for a particular customer, it's going to go to that particular server, or you can do it automatically using software that does it for you, or these new SQL databases, which are basically distributed relational databases that do it for you. Ultimately, the reason why people don't use relational databases for all of their data is that all of their data no longer sits in one computer. It can't. There's just too much information. But they still want to use relational databases for doing reporting, using BI, or fast processing, right? Bringing data in, doing some fast processing, and then saving it somewhere as a cache into another place, into another non-relational database. Key point is SQL is a major part of data engineering. In distributed computing, especially in Spark, and in Hadoop, in the Hadoop ecosystem, Hive is a way to access information that's stored on disk using SQL. Hive is basically implemented as Spark SQL. And another technology that we have covered in some other webinars, it's called Presto. So Presto came out of Facebook. It represents, I don't know if it's really virtualization of information, but it represents remote data sources as SQL tables and SQL databases. And then you can do joins between different data stores. Let's see what databases it supports. Presto, they used to show it. There we go. So maybe this is a bigger picture. So Presto, well, Starburst is like a commercial distribution, but Presto can talk to HDFS, SQL Server, even Kafka or Cassandra, and it gives a SQL read view of that information, and you can do joins between databases. Key point here is it's using SQL. So all of these different BI tools can use SQL to access massive amounts of data. So if for example, and I don't think this is going to happen, if relational databases ever go out of style, SQL as a language is going to stick around. It's just amazing how it's like a cockroach. It doesn't die. So that's my kind of brain dump of what I think people should know about relational databases from a starting point. Any questions, any comments, any advice that somebody wanted to add? Okay, great. Well, that brings us to the end of today's session. Don't forget to go to the YouTube channel, which Akwi, I'm going to put it back here, and I'm going to show it. You can subscribe to the YouTube channel, and we have a Data Engineers Lunch playlist. You can go through and catch up if you want. And anything else, Akwi, before we call it a day?
Nothing else. Just keep an eye on the anant.us/events page for upcoming events for the year.
Oh, we had one question. So Chuba just asked about Hive. So Hive is a way to access information from various different data sources. It does run on Hadoop, and it was a part of Hadoop, and now it's a separate system. So to use Hive, you have to have a distributed data store, and then you use Hive in the Hadoop ecosystem in the sense that like you execute Hive on Yarn or MapReduce2 or whatever, and it takes an SQL query to access that information. It's not necessarily like Presto, because you can have, you're closer to the data. You're closer to the data than Presto. In Presto, it kind of virtualizes it. And by the way, Presto works well with Hive because it can store the metadata for all of those other data sources in the Hive metastore. So before, and also Hive is essentially implemented in Spark SQL. And in it's, how do I describe it? As different from Presto. So here's where I think your Hive also does inserts. That's the other thing. And you can do some deletes on it, right? It's representing data in SQL. Whereas Presto, as far as I know, you're just doing reads on information. I think that's the major difference. But there is some overlap. Yeah, there is some overlap. Does that?
I guess, Rahul, for if you have a requirement for reading a lot of, different data sources, Presto, suits the bill there. It matches their perfect requirement. Whereas if you're doing some cataloging and you don't know, they don't have headers or column names, things like that, and you want to extract some sort of information from it, then you can do some cataloging with Hive and then go from there. But as you said, you can do write with Presto.
Yeah. Thank you. Yep, appreciate that. Is that good? Yeah, so Chuba is satisfied. I think that was it. If there aren't any questions, I'll give you back 3 minutes of your day. Hope you guys have a wonderful official second week of the year, actually, because apparently because the first was last week. Last week was the first week of the year. Enjoy the beginning of 2021, and we'll see you next week, same time, same place. If you want to present something, either on the data engineers roadmap, or if you want to talk about some data wrangling that you've done and showcase it, please let us know. I'm going to put Akwi's email address here. There we go. If you're new and you're building out your career, every presentation that you do and you put on SlideShare and you put on YouTube is huge for you. So especially if you're new, we'd love to have you talk about something that you're doing. It doesn't have to be super advanced, right? It's just like, it's a way for you to build your career on here. That's what part of the community is to get your name out there, right? So I'd love to have any of the newer people in data engineering present, okay? Thanks all, have a wonderful week, and we'll see you next week.
Thanks.
Thank you.
Thank you all.